And finally, I want to talk about a type of dating that is a little bit different. If you remember from the previous couple of lectures, I said that absolute age dating is almost always done by dating igneous rocks. It's dating the time a crystal forms. But you have probably heard of something called carbon dating, or called radiocarbon dating, or what I'm calling here carbon-14 dating. It's probably the type of absolute age dating that most people know of or they'll talk about, so people in the general public, but it's very, very specific, and it doesn't date the date of actual crystal formation. In this case, it actually does take fossil material and puts a number on it, puts an age date on it, but it's a little bit different. It's tricky. I can't date very, very old things with it. So this half-life of carbon-14, if you go back to a slide in the previous couple of lectures, I said, well, here's a few sample isotopes and their half-lives, and most of them were huge, 700 million, a billion years old, something like that. The half-life of carbon-14 is very short. It's about 6,000 years old, really about 5,700 years old. So if you think back to the decay diagram, half of it is gone in 6,000 years. There's only 25% left in 12,000 years. In 18,000 years, there's 12.5%. And if you go and follow that out, by the time you reach stuff that's about 70,000 years old, there's nothing left to measure. So people will say, ooh, I carbon dated those dinosaur bones. You can't do that. You can do things like the animals here, mastodons, mammoths, saber-toothed tigers, things that lived, the example you see right here, the Pleistocene, 15, 16,000 years ago. Turns out we can use carbon dating for things about as old as 70,000 years. That's about the oldest. That's really pushing it. So we can date fossil humans and fossil creatures like the ones you see here, but for most of geologic time, there's no carbon-14 left in anything. Well, let's talk about what it is and what it isn't. So these last few slides are all the same thing. I'm just following the logic that's going on here. There is this unstable isotope of carbon, which is called carbon-14. It has a certain number of protons and a certain number of neutrons, but it's different than regular carbon. Its half-life is about 5,730 years. And where do we get it? Carbon-14 is created in the upper atmosphere. The atmosphere, some of you know it, some of you don't, but the atmosphere isn't mostly oxygen. That's what most people think. We breathe oxygen. That's what the atmosphere is. It's 20% or so. Most of the atmosphere, 70% plus, is nitrogen. A certain amount of it is nitrogen-14. So they have this little atom, nitrogen-14, buzzing around here in the atmosphere. Well, we have this sun, and it's just blasting us with cosmic radiation, and it causes a different type of radioactive decay that I haven't mentioned before, called neutron capture, where a neutron is pulled in and we create carbon-14. Carbon-14 is created in the upper atmosphere. Since it's in the atmosphere, all those plants that are photosynthesizing absorb carbon-14, along with all the other carbon they have. These plants then are eaten by animals. So here's a sheep grazing on grass. That grass has carbon-14 from the atmosphere. That sheep is eating grass with carbon-14, therefore it has carbon-14. And as long as these things are alive, they're going to have a steady, constant amount of carbon-14. Now, if they die, this sheep is no longer eating. This tree is no longer photosynthesizing. Their bones and leaves and limbs and all this are now part of the soil. And what's happening? The carbon-14 that was in them, which is radioactive, is spontaneously decaying. So it is spontaneously changing back to nitrogen 14 because this is no longer eating. This is no longer photosynthesizing. And so if we find a bone or a tooth that is not that old, remember, less than 70,000 years or so, we can measure the amount of carbon-14 in it, and we know that decay rate, that half-life. We can tell how long or how old that tree has been there, how old that bone is. So for carbon-14, the moment that you have 100% parent is not the moment of crystallization. It's the moment that that animal or plant died. So we have all kinds of fossils of things in the relatively recent, bones, teeth, charcoal, pollen, all of that. We can age date it with carbon dating. So it's excellent. It's an excellent tool, and it tells us the dates exactly of the things we want. Ancient humans, ancient mammals, and saber-toothed tigers and things like that. But it only goes back about 70,000 years. What happens when it decays? Well, it decays and it becomes nitrogen 14, which is very light, and it is constantly oozing out of the soil all the time from all these decaying things. It goes back up into the atmosphere only to get blasted by cosmic radiation and start the whole cycle again.